Hello, welcome to the podcast of Wageningen Alternative Protein Project, where people talk about their work in protein transition. I am Shan, a master's student in food technology, and I will be your host today. Our guest today is PhD candidate Regina Politiek. Hi Regina, thank you for being here. How are you?
Hello, Shan. I'm good. How are you?
The weather these days in the Netherlands is super nice. It's almost like it's summer.
Yeah, it's also really warm outside at the moment. It's very nice.
Yeah. Would you like to tell us a little bit about yourself?
Yes, of course. Yes, I'm Regina Politiek. I studied my bachelor in Wageningen and also my master I did in Wageningen. And currently I'm doing my PhD at food process engineering. Next to doing my PhD, I also like to doing sports. So I play volleyball next to that.
Oh, nice. Recently, it's okay for sports club to hold activities again, and it must be really nice for you to be out there, play with your team.
Yeah, I have to say the nice weather is playing a good part in being more outside again. We are now playing on the beach. So,
Yeah, that's nice. So, what is the title of your PhD study?
the title of my PhD study is Dry Fractionation of Oil-Rich Crops. So actually, what I'm looking at is the fractionation of the more seeds that have more oil inside them. And I'm working on dry separation methods for these materials to create a more sustainable process, a cheaper process, and a clean labeled process. Yeah, this because the conventional process is wet fractionation, and that uses a lot of chemicals. And also, if you use wet separation, you can imagine that you add a lot of extra water.
Mm-hmm.
And the addition of water also leads that you need to evaporate the water again. And evaporation processes can be quite energy intensive. And as we need to go to a more sustainable way of producing as well, dry fractionation might be an option.
What was your motivation for doing this project, actually?
My motivation for doing this project was that I was interested in all the components that are in there. So during my master, I studied sustainable food process engineering, and the courses on sustainability really caught my attention actually. And I really would like to contribute on also making other crops than, for example, yellow pea available for dry fractionation.
Mm-hmm.
And yeah, the nice thing about all these plant materials, they are very upcoming, is that they have a lot of different materials that can be applied in ingredients and that not need to be so concentrated. So for example, the crops have quite some protein, they have some fat, they have some fibers and some starch. And I think that got really my attention. And then I think dry fractionation in combination with my interest in these components made me very motivated to choose this topic.
Can you tell us what actually is dry fractionation?
Yeah, so dry fractionation is a method that is based on separation on physical separation. So if you have, for example, yellow peas, they have larger starch granules and smaller protein bodies. So they have a difference in size and also in circularity. And yeah, you can compare it a bit with sieving actually. So if you would have large particles and small particles and your sieve side is somewhere in between, you will collect the large particles on top of your sieve and the smaller particles will fall through and you will collect them on the bottom of the sieve. And then you actually have two physically different fractions. And one fraction is then more, for example, in the case of larger starch granules and protein bodies, one is more rich in the starch granules and the other is more rich in protein.
Okay. So you just mentioned that your PhD is focused on oil legumes, so the oil body in the seeds. What is so important about oil that's related to dry fractionation? Like how does oil interfere with fractionation, I guess?
Well, if you could maybe imagine if you have peanuts, for example, they're very high in oil content. And before you can apply dry fractionation, you first need to mill the material into a fine flour, like powder sugar or something like that. And you can imagine that if you take whole peanuts and you mill them, that you will end up with a sort of peanut butter. And you cannot really sieve the peanut butter or separate the peanut butter, because you get all the oil outside of the particles. But there are also crops that are a bit lower in fat content, or you can defat the crops, and then afterwards you can still apply dry fractionation. But yeah, research on that is still a bit lacking. Oil is also important because it might affect your properties of your final product. So you can imagine that, yeah, when you have oil is also known to oxidize, for example, quite easily. So oxidation might be, for example, a problem when you have fractions with more oil than less oil or something like that.
I can imagine that if before the dry fractionation, the oil need to be extracted, then probably organic solvent will be used in those process. And I guess using organic solvent isn't the most sustainable way of dealing with this, right?
No, that's indeed true. So that's also with the oil-rich crops sometimes the problem. Most conventional processes use the solvent extraction because it's quite efficient and you can extract most of your oil. But there are also other processes, like for example, cold pressing or normal pressing, where you apply a pressure to extract the oil from the seeds, and then you end up with a sort of, yeah, with a cake or with a compressed material which is depleted of oil. But yeah, you cannot really extract all the oil with pressing, for example. Also with solvent extraction, mostly some oil will still be left in the material.
So it sounds like dry fractionation is a way that you leverage on the original structure of the plant material. So instead of using water, which is a really energy intensive process, the structure difference could be used to our advantage in separating the different fractions of the crop. But is there any disadvantages of dry fractionation as compared to the traditional wet fractionation?
Yes. So the advantages are indeed that you have a lower energy and water consumption, but the disadvantage can also be that you need a physical difference. So if all your particles are the same size or are not getting any difference physically, they cannot really be separated. And another disadvantage is that you get lower purities when you use dry fractionation. Yeah, to explain, these lower purities are a bit related to the composition of your body. So for example, if you have a protein body, it's not 100% protein, but it also consists of some other materials. And with wet fractionation, you can go to more isolates, and with dry fractionation, you will end up with more concentrated products.
So is there a tendency for oil to stay with the starch fraction or the protein fractions?
Well, actually, with the oil rich legumes, they don't consist of a lot of starch, actually. So if you have, actually you can see it like the following. So an oil rich legume is actually storing its energy in the oil, and then when the crop needs to grow, for example, when you plant the seeds will use the oil as a sort of energy mechanism. And for starch rich legumes, the energy is conserved in the starch granules. So actually, when you have an oil-rich crop, you mostly don't have a lot of starch in there. So you're actually separating different structures.
So then it's actually very different situation for starch-rich or oil-rich plant seeds.
Yeah, so the oil-rich materials, you mostly separate the proteins from the fibers that are present in the crops.
It sounds like the way to separate the oil from the plant seed, you still kind of crush the structure. So either you press it or you probably mill it and then use organic solvent to track it out. But is there a way currently possible to just separate the oil body, intact oil body out of the seed?
Yeah, you can separate the intact oil bodies with several processes. For dry friction, yeah, you have to see it like the oil bodies are really small compared to the protein bodies. They are like around 2 micron and protein bodies around 10 micron, so they're really small. And with dry fractionation, they tend to stand with the fine fraction, so to say. So the oils tend to stand in that fraction. I have to say I'm not really sure which specific process at this moment is able to separate the oil bodies, but I know that quite some people also are looking at extracting whole oil bodies, and that's because they have like a nice protein layer around them. So for emulsions, for example, they are quite nice to have them as a whole and not as only fat.
What are some challenges that you're faced with when you try to study the role of oil in this process?
I think one of the main challenges is that people are quite often tended to say, yeah, if you have oil present, the process doesn't work, or that it's reported, yeah, it's because of the oil. But actually, when we look at some processes, sometimes it seems not to be the oil, but for example, water content that is playing a larger role in the final separation than the oil itself.
So by water content, you mean, for example, for the seeds, how dry are they when they go into the process? Is that what you mean?
Yeah, so indeed, how dry are they? But also, it also depends on what kind of air you have. Sometimes we have that in summer, some experiments work better than in winter. Actually, the operating temperature of the equipment quite matters, or temperature, but we are located, or first we were located in a location that didn't have really conditioned airflow. And then you really, yeah, you're dependent on how the weather is outside. But now we got conditioned airflow, so I'm quite curious what will be the result of that.
Yeah, that would be nice. Instead of having to wait for summer to test on the effect of a higher temperature. That's gonna take a long time.
Yeah.
Did you notice some differences in the oil seeds that you investigate, like differences between soybean, rapeseed, and sunflower? Are they really significant in designing the process for them?
Yeah, I saw some differences actually because they are also different in fat content. And soybean, I was quite happy about it because I could quite mill it into a fine flour you could also find in the kitchen. And for separation, it could also be separated. For rapeseed, I was also able to mill it, but a bit less fine than the soy. And it has also a bit higher fat content. And the sunflower seeds were like, without extracting the oil, you could not really mill them finely. So yeah, for that seeds, you cannot say I will just use dry fractionation without defatting. You really should defat these samples. Well, for soy, you could also use the full fat one, for example.
I guess the difference between legumes and other plants also matters in the structure of the seeds in this case. Because I also can imagine that the beans might be easier to mill than nuts, like sunflower. That's kind of like, in my mind, it's kind of similar to a nut.
Yeah.
It might become more pasty, I guess.
Yes, indeed. So with the sunflower, we tried and we indeed got like the whole mill got a sort of paste of sunflower material. So it was a sort of sunflower peanut butter, but then yeah, so that was not really possible without defatting.
That's really interesting. As in, there are a lot of oil-rich crops, and currently, I guess almost all of them will need this oil extraction step before processing further. If a better method could be found out, then it's definitely going to be a big improvement in the production, and maybe new variety of ingredients possible produced by that.
Yeah, I think so. But it also doesn't have to be a bad thing if oil has to be extracted prior to further fractionation. If you can also deal with residue of oil. So if you don't need to extract all the oil, it might already help for the whole process, let's say.
Just reduce the amount of oil.
Yeah. If you would reduce, like take out everything, you get also other problems again with dry fractionation. Because if you take, let's say if you take out all the oil, your material becomes really sticky actually, because it's so fine material, it will also give problems.
Oh, that I didn't know.
So yeah, there is always a bit like a trade-off where it's ideal and where it's not ideal.
So apart from what you just indicated, that the existence of lipid in the fractions might influence first of all, the actual characteristic of the fraction, like whether it's pasty or is it a fine powder. And also, you also mentioned that the oil lipid oxidation could be a big problem in terms of storage and stability of the fractions. But apart from that, are there any other influence, like maybe sensory indication for the lipid existing?
I did not study the sensory indications yet, but I also studied some less conventional materials, and their dry fractionation was applied to insects. Actually, and they really found a difference in the fine fraction and the coarse fraction. They didn't really find the difference in protein content yet, or it's not optimal yet. I have to say the coarse fraction was less powdery and the fine fraction was more powdery, and that the fine fraction was more liked actually than the coarse fraction. But still, functionality-wise, I think there were some other differences. I cannot recall them right now, but there are sensory differences between the fractions. And also, if you have a higher protein content, it might affect your foam stability, for example, or your foamability. So the fractions will both have different properties.
Yeah, because I can imagine that whether you extract the oil from the crop before you fraction it, will lead to really different fraction. Then I was just wondering if there are some like taste difference that you might have noticed during your experiments.
Unfortunately, we are not allowed to taste the products that you make.
Okay.
Or some we can. So if you really clean the machine well, you can use air classification then to produce fractions that you can sort of eat. But we also have another system that is called electrostatic separation.
Yeah.
And that is more based on the electrostatic charge that the materials get. And I think, that is also in the lab. And I think that's not a food grade lab. So then we are not allowed to taste it.
That's kind of a shame, right?
Yeah, sometimes. But on the other hand, you can smell it. And I also know that PhD before me, she worked on baking breads of these fractions. And then the lab smelled really nice.
Oh, like a little bakery every day you go to work at.
Yeah.
That's so cool. So after hearing about your research, what kind of research is generally done in the chair group where your project is located?
So my project is located in the drying group of Maarten Schutijzer. And within the drying group, we do quite a multiple things. We worked on freeze concentration. We work on the spray drying of different legumes, and also, so for example, the asparagus is used quite a lot. We work on 3D printing as well. So really 3D food printing with all kind of different materials are printed. We work on single droplet drying. So that's actually, also more on the drying, but then on like drying of really one single droplet and then using that for further altering your drying process or understanding what's happening in the drying process. Yeah, I think we also have someone that works now on a really large scale spray dryer. So she's now located in Germany, but she will come also here. And we also have really large equipment for that.
Ah, nice.
And in the bigger group, we have also people work on microfluidics, on meat replacers, and on the digestibility, for example, and all other things that are done in food process engineering.
What do you think is the most important skill set for researching in this field, or let's say just in your project?
I think the most important skill is that you're curious about why something is happening and that you don't give up when someone says, it's not possible, that you try to find out or why it isn't possible or how you can make it possible or something.
So perseverance and curiosity?
Yes, I think so.
What about the technical aspects? Any specific area of knowledge you need to have?
Within food process engineering, it's really nice if you have some insight in the sustainability aspect and also in how this is calculated, for example, or how it is defined, because you can have quite some discussion on how sustainable a process is and what makes it sustainable or what doesn't make it sustainable. And there are always multiple factors in there. And I think that is quite helpful within the group if you have some knowledge on that, but it's not a prerequisite. I think you can also, if you're more interested in the process yourself and you're really good at, for example, modeling or like interpreting a process, it might also be very helpful because there are also some people just working on modeling a system. They have like a really large data set and they try to model or to predict what will happen if you use certain combinations or certain steps in there.
It's really interesting that you mentioned the sustainability related knowledge. When people think about processing, then it's all this engineering and calculations and like to actually how to improve the process itself. But I guess in this group, in your group, researchers are really pivoting on the sustainability advantages of the technology. So that's why it's also important to know how to deal with that in the research, right?
Yes, and I also think if you really want to be a process engineer, it's important to take the process or the sustainability impact into account. Also, if you are deciding to go, for example, to industry, it's good that you are aware of the sustainability and how to find out how sustainable your process is, for example.
Yeah, definitely. Since we're talking about sustainability, what is your view of alternative protein and its future development?
I really like alternative proteins, actually, I have to say. So we have like plant proteins are like the crop where most people go for as an alternative protein crop.
Yeah.
But actually for plant proteins, there are a lot of crops to discover. I think there are like 9 crops where most proteins are coming from at the moment.
Mm-hmm.
But you can imagine the world is so much larger than only 9 protein crops. So there are lots more crops to be discovered there. For example, crops that are tolerant to drought or that have just different properties, and they are still undiscovered or unexplored. So there is a lot of potential. And also, other protein sources are, for example, insects or algae or single cell cultures. And I think these novel protein sources are also quite interesting to look at.
Yeah, that's very true. Like this is I guess a really really big field in which involves a lot of different sources and different processing method and different, I guess, product design or production method as well. So I totally agree that at least in Wageningen University, I guess the source could be a really nice area to explore on.
Yes. And I think within Wageningen, collaborations should also be done between different groups. For example, plant breeding and processing can be related. Only plant breeding takes a lot more time than processing them,
Yeah.
I think.
I think now there are researchers collaborating between processing and bio-based research, right?
Yes, there are a lot of collaborations with also with food and bio-based research.
Oh, that's nice to know. Do you have personal hobbies related to the transition of protein? Like, have your knowledge or your research in this field influenced your lifestyle in some way?
Yeah, I think a little bit because I'm more curious on trying more meat alternatives, and also because like there is so much in the supermarket. I really like it.
Yeah, yeah.
And then you get also your favorites, like, oh, I really like this one, but that one is not there yet, or it's not, the flavor is not so nice, or the texture is not so nice yet. But it really made me explore them more than when I arrived at Wageningen, I think 7 years ago now. Yeah.
Which meat analog is your favorite?
My favorite is the wokstukjes, I think.
Ah,
You can really nicely use them in a nasi. So it's really fast, really easy food. I really like it.
I should try that out. I haven't tried it yet. Anything you want to tell the fellow students in Wageningen who are interested in this field?
Yeah, I think if you're interested in this field, it's nice to explore what is there and what is possible, because there are a lot of projects on development of sustainable and novel protein sources.
Mm-hmm.
And it depends a bit on where your interest is. Your interest can be really in the processing of these sources, or in, maybe more in how the process should be more sustainable.
Mm-hmm.
Or, it depends a bit, or really on the functionality of the product. So it depends a bit on what your interest is. I think if you really want to work on a project within the field, you should actually also think about where do I want to work on the project? Do I really want to work on the like plant breeding sort of, or more on the process, or more on the functionality or sustainability? And the sustainability takes a bit everything into account, of course. But
That's really good a suggestion, because this is a super big field. So finding the direction around in it is also an important thing to do before actually deciding to, for example, join a research project.
yeah, and you can always ask what kind of research they are doing. If they're more focused on the process itself at this moment, or more on the functionality and finalizing the product, so to say.
Mm-hmm.
But it can also be combined. That I also have to say that sometimes like everything is sort of linked and combined together. But
yeah, I can imagine. So for your project, it's actually currently accepting positions for master's or bachelor student thesis, right?
yes, I have currently one master student, but from September onwards, I will also have a position open again for new students.
Nice. So I guess we should apply for the deadline.
Yeah, if you're interested in dry fractionation, you can apply, and otherwise, I'm happy also to see you in the open house, for example. I think we have that soon again.
I will definitely go there.
Then I can also show a bit more pictures. That makes it a bit easier.
Yeah, Any activity would you find interesting for us as an organization to organize for promoting alternative protein on campus?
I'm thinking that if you want to promote something, a tasting session might be quite nice.
I think so as well. And food is something that really connects people. So it's a good way to raise people's interest for sure. But now in Corona time, it's a bit difficult. But after that, we should definitely organize something like that.
Yeah.
Thank you, Regina, for sparing your time for us today and your sharing on the interesting topic of dry fractionation. And I guess good luck with your PhD project. And I hope to talk to you again very soon.
Thank you for having me, Jean. And I hope to hear from the students soon.
Thank you for listening. If you have enjoyed it and would like to hear more interesting interviews about alternative protein, subscribe and follow our Facebook page of the Wageningen Alternative Protein Project. Thanks again, and we will see you in the next episode.